So this question looks like it is a diagram question. More specifically, it is a graph question. So what I love about graph questions is once you pay attention to the title, which in this case is total protein and total fat for 8 sandwiches, followed by the x-axis, which in this case is total protein, and the y-axis, which in this case is total fat, we can always just kind of pinpoint one of the data points that is graphed and use that as a way to interpret what we see here. And if you can do all that, you pretty much understand how the graph is laid out. So the point that I've circled, again, I'm going to assume, right, 1, 2, 3, 4, 5, 6, 7, 8, right? So that point is one of the 8 sandwiches. And based upon where it's located, I see that this particular sandwich has about 30, let's say 35, 36 total grams of protein, and then about 56, 57 grams of total fat. So the actual question says the scatter plot above shows the number of grams of both total protein and total fat for 8 sandwiches on a restaurant menu. The line of best fit for the data is also shown. According to the line of best fit, which of the following is closest to the predicted increase in total fat in grams? So total fat, remember that's our Y value. So the predicted increase in Y, or predicted increase in total fat in grams for every increase of 1 gram in total protein, which again was our X value there. So hopefully this sounds familiar to you, because if we're looking for a change or increase in or change in Y with respect to a unit change in X, this is equal to slope. Okay, so then based upon the line of best fit, we're just trying to figure out, well, what's the slope of this line? So the best way to do that is to find points that are easy to maybe estimate. So let's see, for instance, if we're looking at the line of best fit, I could say, well, this point right here looks like it's just at 10, 20. And then although this is not exact, this point right, or that position on the line right there is at just about 30, 50. And I know it's not perfect. In fact, let me erase those so you can see it again, right? So I'm looking exactly here and here. And why am I choosing those points? Well, because they are the closest points on this graph that actually cross intersecting horizontal and vertical lines. And because I'm looking for the slope based upon the line of best fit, I don't have to focus my attention on the actual data points that are here, although they pretty much are all on the line. But instead of me focusing on like, well, what exactly is the X and Y value for that point, or what exactly is the X and Y value for that point, I'm going to choose these points here that I initially indicated, because those get me very, very close to an intersecting point between the X and Y values. So how do I find the slope given this information? So remember, slope is Y2 minus Y1 over X2 minus X1. So I'm going to call this X1 and call this Y1, call this X2 and Y2. And so to simplify this, I end up with 50 minus 20 over 30 minus 10. 50 minus 20 is 30. 30 minus 10 is 20. Cross those zeros out, we are left with 3 over 2, or 3 halves. I see that all of my answer choices are decimals. So 3 halves as a decimal is equal to 1.5. If you did not know that, remember this is the calculator section, so you can definitely just throw that into your calculator and see that that's 1.5. I see that 1.5 is an answer here. There's nothing else even remotely close to 1.5 there. So for sure, choice C is the best answer.